Well, it looks like we've got Josh. Hopefully, we'll get more people from Core here soon.
Yeah, I hope so. I added another topic to the agenda, Marco, about a project that I'm thinking about for an interview starting in a couple weeks.
Oh, excellent. Yeah, I see that. That's a great idea.
I think we'll need some input from a lot of folks to understand what would be most useful to collect there.
Yeah, I think so. We had an intern working on something that wasn't this, but it was kind of similar in a way with CBT results. And I think the trick to making something like this work well will be to make it really easy to change the schema for the data that's collected and regenerate whatever the kind of central repository it is from the raw data easily without having it all kind of be fragile and prone to falling apart when things change.
Yeah, certainly it would be like a very loose. It would be no set schema. It would just be a JSON blob.
Oh, I see. Okay.
That's kind of how telemetry works already.
Okay. So you probably will need at some point to index the whole thing, right? It'll be too slow if it's just raw JSON if you have tons and tons and tons of performance data.
Well,
But the important thing,
Postgres actually has JSON support, so you can kind of query different kinds of fields within it pretty easily.
will it create indexes for that raw JSON data then?
I believe so, yeah.
Nice. Yeah, that's exactly what you should do because then you can still do fast queries against it, but then keep all of your data in a nice loose format, like JSON, human readable format like JSON. That's
Yeah,
neat.
yeah. But yeah, we can always generate indexes later as well, like you said, as long as we have the original raw data.
Yeah, yeah. I haven't looked at any of the databases in years, so I didn't even know that Postgres let you do that. That's cool.
Yeah, I think it's probably an addition in the last like 5-10 years or so. They had support for JSON more directly.
Yeah, I'm probably like 10 years out of date at this point.
Yeah, me too.
Cool. That's fun. Yeah, if that sounds like a really good project. It'd be super interesting to see what yeah, we've got a couple of perf counters that'd be really interesting to see over
Yeah, yeah.
over like large data sets like that.
I'm thinking there may be a lot more that we don't have that would be really interesting too.
What did you have in mind?
I think it's about like distributions of different parameters, like maybe distributions of IO sizes or uh, bucketing IO into different types beyond just read and write.
Sure.
Um, Maybe things like even at the booster level of like distributions of O-node sizes or number of X headers or OMAP key value pairs you have associated with the objects.
Yeah.
To kind of try to get a view of the aggregate kind of data set distribution and the workload distribution. That makes sense.
If we get the yeah, if we get the age binning in, we can also then start seeing like how cold the O node versus OMAP data is relative to each other. Like is
Yes.
that
I
could
think
be really interesting to see.
yeah, there's probably a lot we could do more with like memory statistics too, and
Yeah, we are.
how effective the cache is.
Yeah, yeah. We have hit rate type stuff for the Blue Store caches, and I think Adam has something that tells us hit rates for RocksDB, right? Is that what yours says, Adam? I think so, right?
Yes, that yesterday I shared with you. It just tells hit rate for block cache.
Yeah, I didn't get a chance to try it yesterday. I ended up following up on some other stuff that I was doing, but today I'm going to try applying those to master and run some tests with them. So yeah, Josh, we could cover the whole thing, right? We could cover all of our caches, the hit rate statistics for all of them.
Yeah.
That would be really nice.
Yeah, that'd be great.
All right, well let's get this meeting started here. Okay, PRs. I did not see anything performance related that was new this week. So if you made something, I apologize. I did not see it. I was quite tired and didn't have coffee yet when I did this, so that's why I'll blame it on. Closed. 2 PRs that I saw. We merged the initial OSD support for C-Store. Yay! So that's super exciting. And Sam gave an excellent presentation on some of his work. I don't know if that's shared publicly or not, but he went over a lot of his thoughts on and cap plans for that. The other pull request that merged, it was closed, was this throttle request sent to monitors here for logging. That I think is just being closed in favor of a new PR. So we should see something replacing that soon. A couple of updated PRs though. Adam, let's talk about your do small right. Do right small. Go smaller. Well, anyway,
Do small
let's
right.
talk about that. Yeah. I again, I did this before coffee. I think I just got it backwards. Let's talk about that after we go through the rest of the PRs, because I'd like to understand it better. Okay. This optimized client. Crimson OSD's client request parallelism. I think Kifu reviewed that after it was rebased, and Kifu and Schwish, I need to say it wrong. Shuhan, is that right? I think they're discussing it in any event. Let's see, RGW, D3N cache changes that got rebased, but nothing else, I think. The work to set container memory limits in Ceph ADM, that also was rebased, and I think Sage maybe updated it a little bit. And then, this actually was supposed to be enclosed. This work to improve the efficiency of ordered map listing by Eric, that also merged. Okay, lots of stuff in the no movement category, but I don't think anything real interesting to discuss right now. All right, anything I missed, guys? All right, then Adam. So Josh, I think, explained to me last week why it made sense, why your PR to change and only do direct IO inside do small right makes sense. And I thought at the time that I understood what Josh was saying, but I was wondering, could you explain it again, because I need to remember.
Okay, my thinking was that since we do a buffering in BlueStore ourselves, we do not want to pollute page cache in any way. If we use in buffered mode writes, then we will pollute the cache, a page cache. And it would be better not to eat additional memory, just to be aware that we can give more space to BlueStore buffers. And And in addition, that's the only place when we even make it possible to do AIO writes that are buffered. All the other cases are never buffered. So it was more like a cleanup from my thinking, because either we cache it in all conditions, or we never make a possibility to double cache in system pages, system read pages. That was my thinking, and there is no really more logic behind that. That's it. I mean, there is a logic. I wanted to make some simplification on AIO writes, but that was a secondary goal.
So right now, by default, like Igor pointed out in the PR, we have blue store default buffered write disabled. So we would not be buffering these writes by default in the current code, right? If we were to adopt the PR, we wouldn't be buffering in any way.
Well, there is one exception here. If a write request is coupled with an additional flag, which is of advice will need, then we set buffered mode to true, and then this write comes buffered at both blue store and IO level. But other than that, well, actually, I'm not sure if this flag is actually by any client, but other than that, by default, we have this blue store default buffered write config parameter, which is set to false by default, and this makes all writes marked as unbuffered.
I'm a little afraid that right now we have blue store default buffered write disabled, so we don't use our own write cache, but we do set. Well, okay. So right now in the current behavior, I suppose then we're setting the flag to whatever buffered is, which I assume is that, right? So right now we're not doing either by default, right?
Say it again, please.
Sorry. So Adam's PR changes it so that we do AIO write. Instead of using WCTX, the write context buffered flag, we just set it to false.
Right.
So right now we default to have blue store default buffered write disabled. So, like you said, most of the time we're already false anyway, right?
Yep.
That flag should be set to false. Not always, but most of the time.
Okay, but I'm like confused here. There are two things. One is our control over caching data in blue store when we do write, and we have a flag for that. It's, let me verify that, blue store default buffered write, and this tells us to cache the data in blue store buffers when we write. That's one thing. And the other thing is that currently, if we buffer in blue store, then for small writes, in addition, we would also buffer in system. And I'm challenging the usability of that.
Adam, the key piece for me now that I'm remembering this, because I was having trouble remembering, I think is that if I remember correctly, we usually set the write context buffered flag based on the value of BlueStore default buffered write. Is that correct?
Yes.
Not always, but usually. So I think I understand now why you want to do this, right? Because if you already have BlueStore default buffered write disabled like we do by default, then already you don't use either cache. You do a direct IO write and you don't use our cache. But when you enable it, then you most of the time should be doing both with the current code. And why would you do both? Why wouldn't you just use our cache or just use the page cache? Is that the thinking?
Exactly. I want to have buffering in BlueStore and not in system pages.
So what we don't know right now is whether or not the caching at the BlueStore level is effective or the caching at the page cache layer is effective doing buffered IO, right? We just know that enabling it may change the results, but we don't understand why. Is that valid? Is that a valid statement?
It's true, but I don't understand value of this statement.
Before we make this change, it seems to me like we need to understand if we see a change in the behavior, are we better off caching at the BlueStore layer or at the page cache layer? My instinct would be we're better off at the BlueStore layer, that we are better off having our own cache there. But what we saw with RocksDB, right, is that in fact buffered IO was far more important than we realized, possibly due to a code bug. We don't know. I just want to make sure we don't end up repeating that same mistake.
Okay, that's correct, and this is I share that concern. That's true. But why would we leave having buffers, a double buffering, basically, only for small writes? Do we remember logic behind that?
I don't think it's probably a useful exercise. Let's just say that maybe it was based on a theory that having like a secondary cache at the page cache layer would be better. So we have a primary cache at the BlueStore layer and kind of a secondary page cache layer. If things didn't fit into the BlueStore cache, maybe they can fit into the page cache. My suspicion is that's probably what the thinking was. If you have lots of OSDs that are all almost uniformly utilized, it doesn't necessarily make a lot of sense, right? You're better off just giving the memory to the BlueStore cache. But maybe if you had one hot OSD and a couple of others that weren't as hot, maybe RGW indexes are on one OSD or something, and there's tons of OMAP entries that can be cached there, then maybe. But then again, that's RocksDB page cache, so or page cache for RocksDB
Okay.
stuff. So yeah.
So maybe let's solve it that way. I will just close the PR because I don't really care so much, and we will save time on discussing.
Oh, I don't. Sorry, I don't think you should necessarily close the PR. I don't know that it's wrong. I just think we should test it. But you may actually be better. I'd like us to move away from buffered IO, especially with libIO, right? It's not really the way it's intended to be used.
So, okay, on the testing front, I really can devise a series of small write tests. I mean, tests that will comprise in a high percentage of a small writes, and try to toggle performance when I crank up buffering in BlueStore. I can do that. I will have some problem with limiting Linux kernel with buffering my extra data. I don't know how to do that.
I can help you with that. You can use cgroups seemingly effectively to do it. That's how I was doing the OMAP testing, by changing the
Mark.
cgroup memory limit.
So maybe let's split that to just our one talk, and you will teach me how to use cgroups to limit caching memory. And I will finish and make the tests just to show what the benefits and costs are.
Cool. Igor, does that... Go ahead.
Well, I think I understand Adam's points about using this config parameter to control just BlueStore cache and do not impact the page cache. This definitely makes sense. Maybe we should introduce an additional config parameter to control page cache usage.
Yeah, that would be cool. That really makes sense. And then just put it everywhere.
Yeah, absolutely. And this way, at least we would be able to benchmark BlueStore cache and compare it against page cache and decide which one is more efficient.
Yeah.
So at this point, I agree with Adam's points. So it makes sense to have this patch indeed. And maybe additionally, we might want an additional fix, an additional patch to control page cache usage.
Okay, so you're saying I should not reduce that logic, but extend it to provide an extra parameter just to allow also caching in page cache, so we could manipulate parameters and get full control.
Right. So I am not sure if it's useful for production, but for development purposes, it might be helpful.
Yeah, a dev option I think makes sense, but dev only.
Well, at least for now, just to be able to benchmark various options in a simple manner, and I believe it's pretty straightforward fix, so it wouldn't be very complicated. So, well, we can definitely go with the current patch, and maybe additionally we might add some more, another one config parameter.
I think that if we are to add another one, then I will just scrap this one and just modify, because it will be like adding and removing. That doesn't make sense. I will just provide additional parameter that will control whether we use buffered I/O or not.
Yeah.
Cool. All right. Well, I suppose I'll go into, I've got just kind of a small update on the OMAP bench testing that I was doing. I'll put the link in the chat window for the data here. So this is the same thing that I showed last week, but with some new updates. If you look at the third tab, the Luminous to Master investigation. So what we saw previously was that there was a really big difference between Luminous and Master. We're far faster in Master, especially when using buffered I/O. And there was some concern about how much faster we were. So I went back and started looking at running OMAP bench against various versions of the historic code that we have. In some cases, I did need to change it somewhat to make it work. The object store interface has changed since Luminous. So I think everything was basically right, though. What I saw is that I don't think there was any one PR that necessarily improved performance overall, but it looks like there were a number of PRs that maybe did. There was definitely something that happened early on in maybe the Mimic period of Master after Luminous was released. That looks like it really improved the set keys performance, but it was still like maybe 4 or 5 times slower than Master at that point. So I didn't figure out what that one was, because the farther back I go, the harder it is to actually get stuff to compile, especially on CentOS 8. But in the Mimic time frame, I thought that maybe it was going to be kind of around this PR 2177, where we changed the flushing behavior and also changed the object store interface, the flushing behavior in BlueStore and the object store interface. But it turns out that had very little effect. It didn't change anything at all, really. What it was, and this maybe should have been obvious to me since I wrote this code, but it was when we introduced the OSD memory auto-tuning. That was what seemed to make one of the biggest differences in all of this. And the reasoning for it is kind of obvious. Prior to this, we statically assigned the caches to the onode cache and the KV cache. It's not entirely true. We had some capabilities in the old code to kind of try to like rob from one and give it to the other, but it was pretty limited and it didn't work right. So it never really kind of did what it was supposed to do, I think, just from what I remember of looking at it at the time. So when we introduced the OSD memory auto-tuning, it allowed BlueStore to allocate almost all of its free available memory for caches to, say, RocksDB, to the block cache. So you could really aggressively cache OMAP if there were very few onodes. So in this case, we only have like, this is actually not right. We only have 100,000 objects, and we have 100 OMAP keys per object. And so in this case, we actually did not need a whole lot of cache. We primarily need everything to be an OMAP, or caching OMAP entries. And so what we're really seeing in this test is actually that the amount of memory that's available for OMAP cache in specifically the RocksDB block cache is much higher. And so a lot of the tests, especially get, is much better. What's surprising to me, though, is that in Master, when we turn off buffered I/O, all of a sudden the performance is bad. So something very strange is going on here, because clearly giving RocksDB more memory for the block cache when in buffered I/O mode helps dramatically. But it doesn't appear to when we set BlueStore buffered I/O to disable, or BlueFS buffered I/O to disabled. So there's still something very strange going on. But that's the PR that really made the big difference in terms of a lot of these numbers that we saw. There are some other ones. I mean, still, set keys is like twice as fast in master as it was back in Mimic when we merged that. So we've definitely had some additional improvements since then. But that was the one that I saw that kind of made the big difference in a number of different places. That's all I've got right now. Questions or comments? All right. Well, then, if there are none, I'll try to next take Adam's work, looking at he developed a PR that will record the RocksDB block cache hit rate numbers in our proof counters. So I'm going to try to work on applying his to master and really try to dig into why we see this dramatic difference between buffered I/O and direct I/O in a test that should be reading everything from the block cache. So hopefully next week I will have some numbers there, and we can maybe figure out how to fix it so that no mode is performing like we expect it to. So, okay, that's it. Josh, would you like to talk about the topic you added? Oh, sorry, yes.
Sorry, just a question. I know in previous PRs, so this is Joshua Bergen from DigitalOcean. I think you've interacted a little bit with Alex Marigon as well in one of the previous PRs kind of related to the series of topics. One of my colleagues. I know one of the traces that you had looked at, if I remember correctly, kind of showed that we were prefetching over and over and over again. Do you have a memory of that from a month or two back? Okay.
Yes.
Do you still suspect that is in play here?
I believe that we have uncovered what that was. Okay. It looks like in fact, Igor is the one that fixed it. Igor, maybe you want to talk about this. This is, I believe, your investigation into delete, iteration during delete, where we were only doing 30 objects at a time.
Okay, so what's the question here?
We were seeing repeated range scans, basically, that were causing extremely slow performance. And I believe it was actually the thing that you fixed, where we were basically rescanning every 30 objects during deletion in PG deletion.
Oh, I see. Yeah, you're talking about PG deletion specifically.
So is that the case you guys were seeing it in? Because that's the big one we recently saw, where we were seeing these repeated prefetching due to range scans.
I have to look up the PR. I actually thought that particular PR was, well, maybe that was PG deletion. The reason I was asking about this specifically is we are running buffered I/O right now, but we've run into a number of corner cases, even with buffered I/O on, where OMAP performance gets really, really bad in with RocksDB on BlueStore, to the point that we're actually considering moving back to file store for our indexes right now.
Oh, jeez. Okay.
And so in particular, like, there's been a few cases where we've seen this happen, but a very easy way for us to reproduce the issues that we see is, say you have a big OMAP, let's say it's 2 million objects or something, or 2 million keys in the OMAP, and then you have a loop external that is doing a list and then deleting a range of keys, delete a range of keys over a rinse and repeat. And what we find is we'll start off deleting at, say, 8,000 keys per second, and that rapidly drops off. Well, I shouldn't say rapidly. Over time, drops off down to like 100 keys per second with this OSD at 100% CPU usage. I'm not sure if you're seeing that same sort of thing in your test as well.
I have seen something that looks a lot like that when we were doing delete range, and you ended up with a ton of tombstones that you were iterating over, but as soon as you compacted, everything got good again.
Exactly, yeah.
Is that what you're seeing?
Yeah, pretty much, exactly. If we compact, the performance goes up. Sorry, I think Iori's trying to talk.
Yeah, and just wanted to add to Mark's comment that perhaps it's not necessary to have range deletes to get this degraded RocksDB state. It seems to me that multiple removals impact the RocksDB performance as well. So it degrades after the performance degrades after massive removals, and one needs to perform compaction to get the performance numbers back. So originally we were thinking that we just get this degradation after deleted range deletes, but it looks like every delete impacts that. Maybe single deletes not that impact that not that badly, but if you apply multiple of them, they still impact the performance.
It seems to me that we need.
This applies to snap trimming, to OMAP removals, and to PG removals.
Igor, it seems to me like we need to have a mechanism by which we can track the number of tombstones, and when we exceed some threshold, then issue a compaction.
Yeah, maybe. Well, in my second PR, which is still pending, I reworked the OMAP removal a bit, and it triggers range deletes followed by the ranged compaction. But this is applied to PG removal only. So snap trimming and maybe manual OMAP removal are still suffering from this issue, and we should introduce some additional means to handle that.
And I guess what I find is odd, and admit we have not done extensive testing on this, so it's entirely possible that we'll find the same problem in FileStore, but I'm pretty sure that when we've run RocksDB in FileStore, we do not see this performance degradation.
FileStore stores a lot less data in RocksDB, so it might have the same problem, you just don't suffer from it nearly as easily or as quickly.
Well, I guess I mean running our indexes. Like we do still have some old Luminous clusters where our indexes are actually RocksDB and FileStore. And so it should be the same amount of data, right? Because it's just whatever RTW is storing as OMAP.
Sure, I just mean there's not like other data in RocksDB as well.
I see. So you're thinking that because BlueStore is storing more of its own allocation state, for example, in RocksDB.
Yeah, I mean, it might not be that. Especially now with like the column family options that Adam introduced. Do you have column families sharding in your deployment?
We haven't turned that on. I wasn't aware that was really a tested available option until Octopus.
Correct. Sorry,
I thought it was Pacific, wasn't it?
Yeah.
Or was it Pacific?
Probably Pacific is probably.
No,
Pacific.
yeah, it's Pacific.
Yeah, so we don't have that
Yeah.
stream yet. Okay.
So which version are you running, Josh, by the way?
A mixture of Nautilus and Luminous. Nautilus, mixture of 14.2, 8, 11, and 18.
Just in case, what drives are you using for DP?
The new generation are Intel NVMe 4 teras. Why am I blanking on this? I'm not sure, but pretty fast. The drives themselves are pretty fast. When we run into issues, it's almost always CPU.
Yeah, it's just chewing through tons and tons of tombstones doing iteration. So anything that does lots of iteration is just it'd be bad until compaction happens.
Yeah, so you're talking about like triggering compaction. My recollection, I walked the RocksDB code on the compaction path a couple of months ago, so I'm going by memory here. But I think they do take some level of tombstones into account in their heuristics in terms of what files they should be compacting in their background compaction. So they do try. One of the worries we've had is, at least in Nautilus, the default configuration for RocksDB might be hurting the background compaction processes in the way that a file store configuration doesn't, in that it sets a older option for the number of threads to use for compaction, versus the RocksDB version has a capability to have like a set of flusher threads, a set of compaction threads, more concurrency, etc. And I'm pretty sure file store by default does not override any of those options, and so might actually have better background compaction behavior, and maybe that's what's compensating here as well. We haven't had enough time to really experiment with that, though.
I don't remember what versions we were worried about, but there was a point at which we were worried about a data corruption issue with multiple compaction threads in older versions of RocksDB, but it might have been pre-Nautilus. We were trying to be really careful about not doing anything that was going to potentially, have problems.
Yeah, I think you're right, Mark. I remember in Nautilus we did update the RocksDB version because those corruption issues were fixed.
Yeah.
And also we did increase the number of compactions also, if I remember correctly.
Yeah. Maybe though we could let RocksDB do it, like allow it to float those. Are you guys seeing that the compaction threads are where you're bottlenecked? Like if you increase that number of compaction threads, does it improve performance for you?
Honestly, we haven't had enough time to really experiment with that at scale in production.
Okay.
We did a major discovery, I want to say about a month and a half back on this, but that was all in controlled lab environments.
Sure. In the testing that we did back in the Nautilus timeframe, we did see that there's a sweet spot where if you have too many compaction threads, it actually slows it down slightly. It's probably like between 4 and 8, I'm guessing. 2 was pretty good. It was like at least in our test, it looked like the benefit after 2 started, slowing down significantly. And then after you went above, like, is your 6 or 8 or something, then it kind of plateaued or even decreased. But your environment might be different, so it'd be super interesting to know if you see similar things or different things.
Right. Okay. Yeah, I think we probably just have to do a little bit more experimentation and digging on our side to come up with more solid, this works, this doesn't sort of information.
Yeah.
The other thing I want to comment on, I don't want to take over if there's other stuff you want to discuss in this meeting, but the discussion earlier about whether or not to write through the OS cache earlier,
Yes.
That's particularly interesting to me as well. We have older clusters where we're basically running RocksDB right on the spinners, like we don't have separated flash for the RocksDB portion. And what we're finding there is a really weird pathological behavior where you write through the OS cache and then do a flush range, essentially, right, across a bunch of buffers and tell it to flush out to the back end. The OS is writing those as a whole bunch of, think 512 bytes, so like fuzzy block size writes down into the lower layers, which are supposed to gather them back up into big writes again via the IO scheduler. But what's happening is the de-encrypt layer is slow enough that little bits of those big writes are actually leaking through and being scheduled to the disk. And so instead of having like say it's a 512 kilobyte write to the disk that's supposed to be just one big chunk, it actually leaks through as 5 or 6. And then we're missing rotations on the disk, which is causing massive increase, well, I shouldn't say massive, but a large increase in write latency. for those writes to disk. So I actually started writing a patch and I kind of abandoned it because I got a bit nervous about it, where I stopped writing anything through the OS cache in buffered IO mode. So we would get the read benefit from buffered IO, but avoid using the cache on the right side.
Interesting. That's super, super useful to know.
So now with Igor's fix, like the reason we had buffered IO was because of the PG deletion issue. So we're waiting to upgrade that system to 14.2.18, and then we'll just be disabling buffered IO on the spinners at that point, because that's really the only thing we know if that was biting us was the PG deletion there. And then that should address the write latency problem for us as well. But I just thought it might be interesting for you to know that.
Yeah, absolutely. All right, Adam. Sounds like that's a endorsement of your PR.
Yeah, it looked like.
All right, Josh. I know we don't have a ton of time, but did you want to try to talk about your topic, or should we move it to next week?
Let's defer to next week. That'd be a good timing for me too. It's a busy day.
Okay. All right. Well then, anything else, guys, that we should talk about this week, or should we wrap up?
Can I pepper you with one more random question?
Oh yeah, absolutely.
Okay, I posted this to the dev mailing list, and I'm sorry to bug on this again. We do have some really old clusters that are still using file store on spinners, and we are constantly plagued by the inode iteration issue in XFS. And at one point, Sage said, "Hey, a newer kernel fixes this," but unfortunately, he didn't specify which one. So I was really hoping that maybe someone somehow remembered which kernel has better inode scanning during flush range. And if the answer is no, that's fine. I was just kind of hopeful.
I do remember seeing him say that, and I don't know what it was that he saw that was. So I think we'll have to find out from Sage, unless someone else knows.
Based off of the time when he said it, my guess was somewhere around the 4.13, 4.14 range, but I mean, I'm just guessing at that point. So, okay, that's fine. Thanks.
Yeah, no problem. One question for you, actually, on your file store clusters, have you done okay with multiple AGs on XFS with file store? That was the thing that really kind of made file store fall over a lot of times.
Oh, our file store falls over all the time for us. Those systems are awful. And rolling them to BlueStore is difficult because they're so slow that we can pretty much only do one backfill at a time per OSD in file store. Okay. And yeah, they're difficult. So we're trying to get to BlueStore as fast as we can on those, but as fast as we can is probably a 1 year plus project on those clusters.
Okay.
So I'm just looking for, hey, if there's some kernel that we can get to that makes the performance a little bit better, that can speed up our roll to BlueStore project. So that's the reason for my question there.
I have no idea what your file store deployments actually look like, but if they're like any other file store deployments I've seen with lots of objects, your directories are just fragmented to heck and back, really, really bad, across multiple accessor groups, assuming that you haven't done it to one.
Yeah, I don't think we've done any custom tuning on those. I'd have to look, but I doubt we have. And they do have very, very high object counts. Yeah, so I don't know. I posted some stuff about this years ago, but the basic idea is that when file store does a directory split, it will then move objects into those directories, but they originally were in a directory that was assigned to one AG, and the new subdirectories are going to be different AGs, probably. Most likely they're different AGs. Not guaranteed, but most of the time they will be. And so then the first set of objects that ends up in that AG are in fact
or sorry, in that directory, in that subdirectory, are from a different AG, then new objects will be put into it. So you'll end up over time, as the directory tree gets deeper and deeper and spread wider, with just a completely random mix of objects at different offsets on the disk inside one directory. And so if you're going to scan that directory, the whole thing is just insanely bad. It's just random IO.
Yeah, it looks like we're pretty much just doing random IO all the time on those things, but it's not really surprising given the workload too. So.
Oh, okay, sure. But it makes things like directory listing super, super slow. That's what we saw anyway.
Right.
So anything that does like a scan over a directory is going to be awful.
Like backfill.
Yeah, exactly. All right. Well, Joshua, thank you for attending. It was actually really nice to hear from somebody that's got a real deployment. I very much appreciate it.
I'm glad that we could make it. We usually have a conflict at this time pretty much every week. So every time we don't have a conflict, we try to listen in at least.
Cool. All right. Well, then have a great day, everyone. Thanks for coming, and see you next week.
Thanks. Bye.
Bye all.
Thank you. See you.